Okay, we are getting into systems of linear equations. So a system is just one or more than one linear equation, and we are comparing them. So what we need to be able to figure out is a solution to two linear equations. What you can imagine or what it will look like is if I have a graph, and let's say I have one line going this way, so there's an equation for that line, and let's say there's a line going this way, so there would be an equation for that line. I am basically looking for this point right here. So this has an x and a y value that satisfies both of those equations for the line. So we are going to be exploring that in this section, how to find that x, that one x and that one y value that is a solution to both of the equations for this line. As a general understanding, what we're going to do, the very first one is solving by graphing. So this is just going to be practice with graphing lines, and I'm going to put all of the equations of lines and slope-intercept form for you already. So really we just have to go through and graph them and see which point each line shares. Okay, so we have two sample problems here. But yeah, if you read through these notes, two or more linear equations in order pair that makes each one true. So we're going to graph and then note the point where they intersect. So we're going to have x equals something and y equals something. Now, when I graph, normally when I'm graphing these lines, you're just showing what the graph is. You're plotting your y-intercept, then you're plotting another known point, and you're drawing a line through them. So when we are actually solving for graphing, I'm going to do it a little bit differently. I'm just going to plot multiple points before I draw my line so that I can be a little bit more accurate. And then we're going to explore how to solve them using a graphing calculator as well. So let's take a look at these two lines. So this is a system, y equals x plus 5. And remember, if there's no number there, there's a 1. All right, and then if there's no number there here, there's a 0. So y equals negative 4x plus 0. So I want you to think of it that way. So what I'm going to do is I'm going to graph each line. I'm going to put this line in blue, and I'll do this line in red. All right, so I'm going to start with the blue, and I am going to graph 1x plus 5. So I'm going to start at 5. So I'm going to go up 5. 1, 2, 3, 4, 5. And I'm going to put my dot there. Now my graph is, or my slope is 1. So remember, it's 1 over 1, so I can go up 1 over 1, and I put another dot there. Now normally I would draw a line here, but I'm going to continue to put dots up 1 over 1 from that point. All right, so now, if you remember, this is also the same as negative 1, so I can go down to the left one. So I'm going to do that for a few points. You really only need to do this for the first one that you graph, the first line, because then you'll see where they're going to meet. All right, so right now, normally I would draw a line through that, but I'm going to hold off on that right now because I want to see the exact point where these two lines meet up. So now I'm going to go to my second graph, whereas y equals negative 4x plus 0. So my starting point is 0, and my slope is negative 4 over 1. So I could go down 4, 1, 2, 3, 4, and then to the right 1. So I could keep doing that, 1, 2, 3, 4, to the right 1, but you can notice that I'm going away from that blue line, and I want to get up to where it meets that. So we know that with our negative slopes, we have to associate the negative with either the top or the bottom. So this could also be the same as 4 over negative 1, meaning I go up 4, 1, 2, 3, 4, to the left 1. Up 4, 1, 2, 3, 4, to the left 1. And there is my line. So we can see right now that where the lines meet are right here. All right, so this is an ordered pair. So on my x value, I'm at negative 1. So negative 1 for my x. And my y value would be 1, 2, 3, 4. 4 for my y. So that is my one ordered pair that makes that true. So if I did draw these lines in now, I can do that. So here's my blue line, here's my red line. But what we are looking for is where they share a point of intersection. So this would be our x value, this would be our y value. This makes both of these true. If I put in -1 for x, -1 plus 5, that equals 4. And if I put a -1 in for x, -4 times -1 equals +4, and it equals +4 there. All right, so let's go ahead and try this. I'm going to do the same thing. I'm going to use two colors. I'll use red and I'll use blue for these. So I am going to go to +2, 1, 2, put a dot there. And let's make this a little bigger so you can maybe see it. So if you're doing this on a computer, just go ahead and increase the size so it's easier for you guys to do. So I have a -1/2. Now remember, just like this example, I can think of this as -1 over +2 or +1 over -2. I'm going to start with this one, -1. So I go down 1 and then to the right 2. Down 1 to the right 2. And I can keep doing that. I like to take my first line and do that a bunch of times so then I can see which direction I'm going to go more for my second line. So just like that, now I can go up the other way, up 1 to the left 2, and keep putting dots in there at known points. All right, that should be good. So now let's check our other line. So this is a -3, so -3 over 1 or 3 over -1. So think of that as your slope. We're going to start at -3. 1, 2, 3. Oop, that's only 2, sorry. So down 3. And now I can go down 3 to the right 1. So down 3, 1, 2, 3 to the right 1. You can see I'm going away from that line, right? And I want to go up this way. So now I'm going to reverse it. So that was the -3 over 1. Now I'm going to go up 3 to the left 1. 1, 2, 3 to the left. 1, 2, 3 to the left. There we go. That's our point of intersection. Let's put another one just for good measure. So now we have to identify our x and our y. Our x value is -2. -2 for our x, and our y value is 1, 2, 3, +3 for the y. So that is my ordered pair. If I were to draw out these lines now, and really I don't mind if you don't draw out these lines, but we're just looking for that one ordered pair that they share, and this is our solution where they intersect. A couple things you may encounter with these types of lines. Most numbers will have one solution. This is one solution, the ones we did examples of, where they have one point of intersection, so they have an x and a y value that make both of them true. There are two other situations you may encounter. They won't happen as often, but if they have the same slopes and different y-intercepts, meaning they're parallel, they will never intersect, right? Because parallel lines go the same direction. There's never a point of intersection, so of course there is no solution. If they have the same slopes and the same y-intercept, I know that sounds kind of weird, but basically they're the same lines. If they give you a set and they lie on top of each other, then they're infinite amount of solutions because they're always the same. All right, so we can also use a graphing calculator to solve and check. It's really important to get the practice in with graphing because that kind of doesn't go away with algebra. But we can also use a decimals calculator to solve for these systems. All right, so I'm gonna show you where that is. If we go to this website, desmos.com, and you can just go straight to the website and get to the graphing calculator. It'll say graphing calculator, but this is the actual website. And then we plug in the equations into the calculator. So I'm gonna go ahead and do that now. So here is an example of the graphing calculator. And I took a screenshot and put it here, but this is how we would do it. So I would just type this in as you see it. So I have y equals 3x minus 4. And you can see it's graphing the line as I put it in. So I'm just going to go down to 2 because I'm going to put in a second line. So I'm going to say y equals, and I'm going to say -1/2, and then x, and then I'm going to put +3 because that's our equation. And now you can see both of these are graphed on this Desmos calculator. Now, if I click on these lines, it's going to give you where that point is. So like further example, this red line, it shows me where the x-intercept is, shows me where the y-intercept is, which makes sense, -4. The blue line, our y-intercept is at 3, 0,3. It's a slope of -0.5, but I'm looking for this point of intersection. So I can just hover right over it, and then I can see what the value for x and the value for y is. So in this case, it's 2, 2. All right. So this is a great tool to be able to check your answers. We're going to be getting to solving lines algebraically where we're not graphing, but we can still input the equations here to check our answers to make sure our x and our y come out accurately. So we will use this for some of the problems that we do as well.